Hey y'all, welcome to Unit 5. Unit 5 is going to be about sequences and series, and 5.1 is going to focus on what we call an arithmetic sequence. Yes, it's the same word as arithmetic, spelled the same, but it's arithmetic when we're talking about a sequence. So a sequence is simply any list of numbers or expressions with a definite pattern. A pattern you could explain to someone so they could find the next number in the list. An arithmetic sequence, that pattern is that each consecutive term differs by the same amount, which we call the common difference. So an arithmetic sequence, each term is found by adding or subtracting the same value over and over again. So we look at these two examples here. The one on the left, 5, 9, 13, 17, we notice we are adding 4 every time. That common difference, we use D for difference. That common difference is 4 because the sequence is increasing by 4 with each term. The second sequence, 20, 17, 14, 11, is changing by -3. So that common difference, D, is -3. Now, if we look at example 1, we are going to talk about finding the common difference for each of these arithmetic sequences. If we look at A, 2, 6, 10, 14, if we look at each term, it is 4 more than the previous term. So that common difference is 4. If we look at the second one, we go from 7 to 2 to -3 to -8. 7 to 2, we subtract 5. We subtract another 5 to get to -3. We subtract another 5 to get to -8. So that common difference is -5. Yes, that negative makes a difference. Don't lose track of those. Pardon me. Y'all are used to my bad allergies by now, right? So a little bit of notation. A with a subscript 1. A sub 1 is the first term or the first value in a sequence. It's the first term. A sub 2 would be the second term. And so on and so on and so on. So, A sub n, A sub as in subscript, n, A sub n is the nth term, nth being a number, or we also call it the general term when it's a formula, the general term or the general rule for that sequence. So, the basic formula for an arithmetic sequence is that A sub n, the general term, is equal to A sub 1 plus D, that common difference, times n minus 1. This is your general term for an arithmetic sequence. Okay, A1 being the first term, D being the common difference, N is the number of terms. A term, remember, is a value in the list. It's a value in the list. So, we're finding the formula for the general term of this arithmetic sequence. This is the one we saw above. That common difference was 4. We're adding 4 to get to each consecutive term. That common difference is 4. A sub 1, that first term, is 2. This 2 is A sub 1. So then that formula for A sub n would be A sub 1 is 2 plus D, which is 4, times n minus 1. Now, we don't want to leave it in this form. We do want to simplify this. We need to multiply before we add. So then this is 2 plus 4n minus 4. We want to combine like terms. So then a sub n is negative 2 plus 4n, or you could write it as 4n minus 2. So these arithmetic sequences are linear equations. A sub n equals 4n minus 2. Y equals m variable x plus b. Now, b is the zero term, not the first term. So we do have to be careful about that. So let's look at example 3. We're going to find the formula for the nth term. So if we look at A, we have A1 and we have D. So A sub n is A1, 3, plus D, which is 2, times n minus 1. Now, distribute, multiply first, then add. Do not add that 3 and that 2 together. So 3 plus 2n minus 2, combine your like terms, and a sub n is 2n plus 1. Now, the idea behind this is that we can plug in any value of n and we can find that term. So instead of having to count 50 terms to get to the 50th term, we can use this formula and plug in the 50 for n and get the 50th term. So there's the advantage to that formula. So let's look at B. B is a little different here, okay? B gives us 2 terms, but it doesn't give us the first term. Okay, it gives us 2 terms, neither one of them being the first term. What we do have, though, is the 8th term, 9th, 10th, 11th, and we have the 12th term. We have a 26 here, we have a 38 here. Okay, so we can treat this common difference like a slope, because it is the slope of a linear equation. Okay, we need to figure out how far we need to go and in how many spaces. So what we need to do to get from 26 to 38, okay, from 26 to 38, we need to go up 12. Is that right? Yeah. We need to go up 12, and from the 8th term to the 12th term, that's in 4 terms. So that common difference is 3. It's 38 minus 26 over 12 minus 8. Treat the value of the term like the y's. Treat the term number n like the x's. So this is 12 over 4, which is 3. And we can check this. If we add 3, we get 29, then 32, then 35, and then we really do land on 38. So that all works. Now, to write that general term, a sub n would equal a1. We don't have a1. So that's what we need to find. Okay, what we do have is a sub 8. So we'll use that formula. Here's the general formula. We need to find a sub 1. So to find that a1, we can use a sub 8. So a sub 8 is 26, which will equal a1 plus that difference we found, 3, times n minus 1, n is 8, minus 1. So 26 equals a1 times 3 times 7, that's 21. So if we subtract 21 on both sides, we get that a1 is 5. And now that we have a 1, move all this over. Now that we have a 1, we can find our general term. Now that we have a 1, we can find that general term. So a sub n will equal a1, 5, plus the difference, 3, times n minus 1. Then 5 plus, distribute first, 3n minus 3. Then a sub n, really make your n's look like they are subscripts. A sub n is 3n plus 2. And there is our general term. So we needed to find the common difference, then use it to find a sub 1, and then use that to write the general term. Okay? Now, I'm going to show you another way to do this without counting and without doing the slope. I'm going to show you that on example C. Okay? A sub 7 and a sub 13. Okay? There's a difference there of 6 terms. From here to here, it's a difference of 6. So, if we start with a sub 13, a sub 13 will equal a sub 7 plus the common difference times 6 minus 1. So, A13 is 18 equal to 15 plus D that we're looking to find times, I did that wrong, that's a 7, not a 6. That's a 7. Times 6 now, that's where the 6 came from. So subtract 15, and 3 is 6 times D. Then divide by 6, and that D is 1/2. D is 1/2. Okay, now we need to find a sub 1. We need to find a sub 1. So we'll use a sub 7. A sub 7 will equal a sub 1 plus D times 7 minus 1. A7 was 15. We're looking for A1. We now know that D, that's a plus sign. We now know that plus 1/2, D is 1/2, times 6. Half of 6 is 3. 15 equals A sub 1 plus 3. So A sub 1 is 12. Now we have the difference and we have A sub 1. We can write the formula for A sub n. A sub n would be A1, the 12, plus D, the common difference, which we found to be 1/2, times n minus 1. We're writing the general rule, so we leave n as n. Distribute. And a sub n is 12 plus 1/2 n minus 1/2. 12 minus 1/2 is 11.5. So a sub n is 11.5 plus, I'm going to make that a decimal so they're all in decimal form, 0.5 n. If you wrote that as a 1/2 n, you are 100% correct. Either way here works. Either way here works. Okay. So let's switch a little bit to series. Series is the sum of the list of numbers. It's the sum of the list of numbers. So this notation, I know it's hard to read on your paper. This notation, the Greek letter sigma stands for summation. It looks like an E, it's a sigma. Okay? The number underneath, I equals 1, that's the lower limit. And what that means is that the first term is a sub 1. Okay? Then the number on top tells you the last term, the upper limit. So the last term in our sum is a sub whatever n equals. Okay? Then this x sub I here is the formula for the terms. And that's really important to keep in mind. The formula is what goes here. Okay? Another key thing here, this number may or may not be 1. The first term in our sum could be a sub 5. If there were a 5 down here, the first term in our sum would be a 5. A 5. Okay? May not be 1. But this number on the bottom will always tell you what your first term is. So, to read this sigma notation, it is the sum of the terms a sub I being the formula, from, I don't need a ruler, from I equals 1, that lower number, to I equals n, that upper number. Okay? I serves a lot like the n does. Okay? N on top represents the number of the last term, not the value, but the number. Okay, a sub I is the rule or the formula, the general rule or the general formula. Should call that the general rule. So, here's that little note I made right here. A sub I may or may not always correspond with the starting term, as in a sub 1, but that bottom number does tell you which term is the first in your sum. So, to sum an arithmetic sequence, okay, an arithmetic series is the sum of the terms in an arithmetic sequence with a finite number of terms, meaning we know the number of terms. We're not continuing to add. So you may see the notation simplified. S, capital S, sub 30, is the sum of the first 30 terms. And that works in this notation. A sub 1 is the first term in the sum. So this capital S notation only works if you're starting with a sub 1. Okay, so in example 4, we want to find the sum of the values 1, 3, 5, 7, 9 up to 95, 97, 99, and we want to do this without using our calculator. This ... here in the middle means that pattern continues. So we're not just adding up these 8 numbers, we're adding up all of those numbers that would fit that pattern in between. I don't know about you, but I am 100% positive if I put all that in my calculator, I would miss something. I would skip a number, I would hit a times so I'm in a plus, I would mistype something, and I am 100% positive I would get the wrong answer. So we need another way to do this. And no surprise, I'm going to show you. So, one way to find this is to think about the pairs. The first term, I need more room than that. The first term and the last term, 1 and 99, their sum is 100. 3 and 97, the second term and the second to last term, their sum is 100. We seeing what's going on here? The third term and third to last term, their sum is 100. And 7 and 93, their sum is 100. Do it one more time. 9 and 91, their sum is 100. So we can pair these numbers together so that their sum is 100. So the odd numbers, every other number from 1 to 99, that's a total of 50 terms. It's half of the numbers from 1 to 100 because it's only the odds. Okay, so with 50 terms, that means there are 25 pairs that add up to 100. So the sum of those terms is the 25 pairs times 100, and that sum is 2,500. Wasn't that a lot better than trying to punch all those buttons in your calculator? Because again, you're going to mess up. I'm going to mess up. It's going to be a big yucky mess. So we have a formula we can translate this into. So summation formula. This is the summation formula for an arithmetic series. Only for an arithmetic series. Okay, only for an arithmetic series. The sum of the n terms is n over 2 times a first plus a last. A first plus a last. So we're looking at finding the sum of these series. Okay, so following this in A, our A sub 1 would be 38. Our common difference, if we look, we are subtracting 5. That negative is going to matter. Okay, first thing it tells us to find is A sub n. That's the general formula. So A sub n is equal to A1 plus D times n minus 1. So A sub n would be 38 minus 5 times n minus 1. So 38 minus 5n plus 5, which means our general rule is going to be negative 5n plus, what was that, 43. Negative 5n plus 43. Now, the next thing it wants is a sub 30. Well, that's the 30th term. We have the general term. So a sub 30 negative 5 times 30 plus 43. And that makes a sub 30 equal, I would put all of that in the calculator, negative 107. Negative 5 times 30 plus 43, enter. And there's our negative 107. Show that to you. Soon as Desmos decides to load. Great. Okay, so that would be negative 5 times 30, the term number, plus 43. There's our negative 107 for the 30th term. Now, we need that 30th term because to find that sum, we need a first and a last. So a first is a sub 1, which was 38. A last is a sub 30, which we just found was negative 107. So using this, we can find the sum of those first 30 terms using the formula from up here. So n is the number of terms always, or the term number. So 30 terms over 2 times a first is 38 plus a last is minus 107. So 30 over 2 times 38 minus 107. So 30 over 2, get out of the fraction, parentheses, 38 minus 107. Put all this in the calculator at one time and let it give you an answer. So negative 1,035. So the sum of those 30 terms is negative 1,035. Okay, so we found everything it asked for. We found a sub n. Wanted a sub 30. Here's a sub 30. And it wanted the sum of those first 30 terms, and there it is. Now, we're going to do the same thing with B. Okay. A1 is 8. That common difference, we're adding 12. So to find a sub n would be 8 plus 12 times n minus 1. So 8 plus 12n minus 12. So a sub n would be 12n minus 4. I keep losing that color. There is a sub n. Now, we want a sub 10, so plug in that 10. A sub 10 would be 12 times 10 minus 4. So a sub 10, 120 minus 4 is 116. A sub 10 is 116. Now, a first is a sub 1 because it says S10, it's the sum of the first 30. That was 8. A last is a sub 10, which we just found out was 116. So when we go to do the sum, those first 10 terms, use the formula at the top of the page. N is 10, that's how many terms there are, over 2, times a first was 8, plus a last was 116. 10 over 2 times 8 plus 116. 10 over 2 times 8 plus 116. And the sum of those 10 terms would be 620. Now, let's look at C. C and D are a little bit different. Okay, C and D are a little bit different because we're given the summation notation. Okay, so what this means, what this 2i plus 1 means, is that a sub n is 2n plus 1. That gives us our general rule. So we don't need to calculate the formula, determine the formula, because we already have it. So, working on this, okay, we're finding the sum of 1 through 24. A first is a sub 1. Okay, a sub 1 would be 2 times 1 plus 1, which is 3. Okay, this 1 gave us that 1. And then a last is a sub 24. So 2 times 24, 24 is 48 plus 1 is 49. Okay, the 24 came from here. Okay, now from 1 to 24, there are 24 terms. So to find the sum of those 24 terms, 24 over 2 times 3 plus 49. 24 over 2 times 3 plus 49. 24 over 2 times 3 plus 49. So the sum of those terms is 624. And there is our sum. Now, there's a little bit of trickery on part D. We're using the same formula. Okay, we're using the same formula. So we have this means that a sub n is 2n plus 1. It tells us a first and a last, the bottom and top numbers on the sigma. So a first is a sub 5, which is 2 times 5 plus 1, which equals 11. A last is a sub, the number on top, 13. 2 times 13 is 26 plus 1 is 27. So there's a first and a last. Okay? Now, what we need to figure out is how many terms. Don't get confused by that 13 on the top because we don't start with 1. Okay? So the fifth term is our first one, then 6th, 7th, 8th, 9th, 10th, yes, there's a reason for my madness here, 11th, 12th, 13th. So how many terms are there? If we count these, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 terms. Now, you're thinking, but 13 minus 5 is 8. And 13 minus 5 is 8. Here's the deal. When we're looking at the number of terms, we include the 5th term and we include the 13th term. we include both of those terms. So to find the number of terms, we would take the 13 minus the 5 and add one more to get 9. If you're ever not sure, count on your fingers. If you're ever not sure, count on your fingers. Okay? So, to find the sum of those 9 terms, okay, that sigma, it's not the sum of the first 9 terms. So we don't want to use that capital S notation. Okay, that sum would be 9 over 2 times 11 plus 27. So the sum of those terms is, sorry, there needs to be a 2i plus 1. That sum is 9 over 2 times 11 plus 27. And that is 171. Sum of those terms is 171. All right, guys, that is it on arithmetic sequences and theories. Bye, y'all.